So to evaluate this indefinite integral, I've got the double angle identities over here, or you might want to have up the power reduction identities, sometimes is what those other ones are called, because you can rearrange this double angle identity here. You can say when you solve for cosine squared x, that's equal to cosine of 2x plus 1 over 2. So that is sometimes called the power reduction identity. So we want to do that with this one because right now we don't have a good u, we don't have good du. We can't use u substitution or any of our other tricks. But if we rearrange it and make it into two terms, because you can break that fraction up into two terms, then we could use the linearity property of evaluating an integral. So basically this is cosine 9x. So 9x is like our x in this variable. So that means this is going to be 18x in here because it's double whatever the original argument was. And so if we break this up into two separate terms, break the fraction up, this is 1/2 cosine 18x plus 1/2. And that's easier to integrate because you can use the linearity property of the integral operator. So this is, when you evaluate this antiderivative, we know the antiderivative cosine is sine, but you have to multiply by 1 over 18 on the outside because of the chain rule. If you were to evaluate this derivative the innermost function would make an 18 come out, so we have to compensate there. And then integral of 1/2 with respect to x is just 1/2 x. So if you simplify that, it's 1/2 1 over 18 sine 18x plus x plus some constant c, plus that arbitrary constant c.